Hello everyone, and welcome back to another cartography lecture video. And in this lecture video, I want to continue our discussion on color by talking about the first way that we can communicate color to a computer through this idea of RGB. And so to recap where we've left off so far, we've talked about how we see color in terms of electromagnetic radiation and additive and subtractive color forms. And we talked about the conceptual properties of color, so that was hue, value, and saturation. And what I want to do in this video is take things a step further and say, okay, well now we know how to describe color and we know where it comes from, but how do we get the computer to actually deal with color? And that's going to be through RGB, CMYK, HSV, are going to be the three common ones we're going to talk about. And then we're going to talk briefly about hexadecimal, which is the way that computers like online formats communicate color. So anyway, let's go ahead and give ourselves a little bit of space here. And what I want to do is I want to talk about red, green, blue, or RGB, also known as red, green, and blue color mode. So this is the first way that we can communicate color to a computer. And the reason I want to start off with RGB is because it's probably the one that you are most familiar with seeing, because it's the way that things like Microsoft Word, Paint, all of the sort of commonly used applications allow us to interact with color. And so it's good to kind of understand where this is coming from. And so what I've done here is I've gone ahead in advance and I've drawn out this what we call a color cube. And the color cube has 8 vertices. It has black down here, white up here, and then red, green, and blue, yellow, cyan, and magenta. Which, if you remember back to our additive and subtractive color discussion, right, these were basically the colors that we talked about most because they were the colors that were responsible for mixing, or in the case of pigments with subtractive, absorbing. And talking about them in this cube fashion makes explaining RGB color combinations, and when we talk about CMYK, it's going to make it very, in my opinion, very intuitive. And so what I want you to do for a second is just pause the video and go ahead and copy this cube down, making sure to pay attention to the orientation because we're going to change the orientation for the next video. But in this video, we're going to have black be the 0 marker, and we're going to have X, Y, and Z be proportions of red, green, and blue, respectively. So pay attention to the orientation and the different points that they're labeled for their colors. Okay, so what I want to do is I want to explain conceptually what RGB color is doing, and then I want to show you in ArcGIS Pro how RGB is handled. So essentially what you can think of for RGB is it's communicating to the computer the intensity of red, the intensity of green, and the intensity of blue that should be emitted, again, using that additive color scheme with the diodes in the back of the monitor. Right? It's telling the computer, okay, how much, right, that's intensity, how much of this particular diode should I activate? Should I crank it all the way up so it's emitting as much as it can? Or should I dial it back and maybe emit a little bit less? So RGB is controlling the intensity of red, green, and blue that are being emitted. That are being emitted. Right, the intensity of red, green, and blue that are being emitted. Right, and so if we look at our little cube here, the way that we can think of this is black would be no red, no green, and no blue, right? You can think of this, I know we're getting into graphs, but you don't really have to understand graphs to really understand what I'm talking about here. But you can imagine that as we go along this line here, right, we're increasing our red. Actually, let's go ahead and state that, right? As we go along this line here, right, we are increasing red. Right, as we go along this line here, right, we're increasing blue. And as we go along this line here, right, this line here, we are increasing green. So you could imagine here that black would mean none of any of the colors, right? This would be no red, no green, no blue. Right, no red, no green, no blue. Right? And if you think back to our additive description of color, that makes perfect sense because we're not emitting anything. So there's nothing to mix. So there's going to be no color. Right? Conversely, if we emit full blue, emit full green, and emit full red, we get white. So this is going to be all the red, right? The full intensity of red, the full intensity of blue, and the full intensity of green, which again is going to give us white. And that makes sense conceptually, again, going back to that additive color scheme, because we're adding equal parts of color at the maximum possible intensity. And so what you can imagine happens here is we end up with this diagonal going from black to white. This diagonal sort of in three-dimensional space, I'm going to do my best to draw it as a gray line. Hopefully I don't make it too messy here. Right, but this diagonal going from black to white, where we're increasing red, green, and blue at the same rate, is going to be our grayscale, where if we have relatively low intensity of all three, it's going to be a dark gray, closer to black. Whereas if we have a higher intensity of red, green, and blue in equal parts, right, we're going to end up with a brighter gray or an almost white. Okay? So that's conceptually how the red, green, and blue color scheme works, is we are simply stating the intensity of red, the intensity of blue, and the intensity of green. And by mixing these together, we can get different colors. So yellow, for example, would be 100% red and 100% green, but no blue, right? Cyan would be 100% blue, 100% red, but no green, or yes, but no green. Right, and magenta would be 100% blue, 100% green, but no red. Okay, so that's how this color cube through the RGB lens works. So let's go ahead and take a look in ArcGIS Pro how this color scheme and color coding actually works. So in ArcGIS Pro, and this is really the same in Paint or MS Word or some other software, when you have the RGB color mode selected, we're describing RGB, which is going to be, again, this color cube here. And so the thing with computers, at least the way that we've constructed them currently, is they run on something called 8-bit color. And what that means is that each one of these sides of the cube here is going to be 255 units long, meaning that we can specify an intensity between 0 and 255, meaning 255 is going to be pure intensity, 0 is going to be no intensity or no emission. Right? So if we wanted to get green, for example, what we would have to do is we would have to say we want 0 red, we want 0 blue, and we want 200 250 green, right? This is the far corner of green. If we wanted something that was a little bit less green, so like a darker green, for example, we would simply cut that in half, say 125. And you'll see that it's gone down to a darker green. If we wanted, say, cyan, right, we could do 255 blue and 255 green. Right, so this is going to be maximum intensity green and maximum intensity blue. All right, so that's going to give us our cyan. Versus if we wanted yellow, right, that's maximum intensity green and maximum intensity red. That would be 255 there and 255 on red and 0 on blue. And you see that we get yellow. And if we wanted gray, right, we could do something like 100 of each. And you can see that we get a moderate gray color. Okay. So let's go ahead and get rid of that for a second and talk about what we just learned. So for ArcGIS Pro and many other softwares, this intensity right here, this is measured as a 0 to 255 scale, or an 8-bit color scale, meaning that each color is specified as 0 meaning no intensity, or 255 meaning 100% intensity. Okay, so hopefully that makes sense. In general, RGB talks about intensity of red, green, and blue, and we can think of it in this cube format. In specific to computers, when we go to communicate that intensity, it's a value ranging between 0 to 255. It's an 8-bit scale, where 0 means no intensity, and 255 means 100% intensity. And as I am looking at this cube here, I am realizing that these two values should be changed. This should be cyan, and this should be magenta. Just based on the fact that 100% blue and 100% red would be magenta, not cyan. So flip magenta and cyan. These two corners are wrong. But anyway, so again, make that correction. And again, we're talking about the intensity describing red, green, and blue light being emitted. Okay. Hopefully that makes sense. Hopefully that didn't confuse you. And as always, if you have any questions, please reach out. Thank you.